Hello and good morning, CTS231, Section 875 students for the Fall 2016 semester at Anne Arundel Community College. This is the CCNP 4 course, or the Connecting Networks course, part of the Cisco Networking Academy curriculum. And this morning's video tutorial is going to be a tutorial and solution set on Packet Tracer Activity 4.4.1.2, where we're going to be taking a look at very little bit of the point-to-point protocol encapsulation, and we're going to spend most of our time with the frame relay configuration and EIGRP. All right, so let's go ahead and dive in here. I'm actually displaying everything on the right-hand side here that we're going to be required to do. So we're just going to knock things out one at a time. So we're going to start with configuring R1 to use PPP with CHAP, the Challenge Handshake Authentication Protocol, on the link to the internet. And this actually makes a lot of sense that we would be running PPP with the internet provider here. And let's go ahead and bring down router 1. And we'll jump onto the CLI. And so the interface to the internet is serial 001. So let's go from user exec to privilege exec into global config. And let's say do show run here. And let's see what serial 001 looks like right now. So you can see we've got this frame relay full mesh. We may not be doing, we're going to be doing frame relay full mesh, and it does not look like we're going to be using any sub interfaces to do that. We're simply going to leverage, like we did in that first activity, I think it was 4214, where we just leverage the entire physical interface as part of a full mesh setup with frame relay. So here we're going to be doing the same thing, and serial 001, you can see that the in cap is currently not set. So if I were to say do show IP interface brief, we should see up down on 001. And let me make this, see if I can bring it over here a little longer. There we go. So you can see serial 001 is in fact up down, right? Remember, the layer 1, the clocking is good, but layer 2, which is that encapsulation type, is not. So let's go into the interface serial 001. And we're going to say encapsulation. Oh, I'm sorry, we didn't want encapsulation frame relay. We'll say encapsulation PPP. I'm still stuck in the last exercise. So encap PPP, and let me make sure that we don't get. Okay, so the encap PPP has been set up. So if we were to say at this point, let's make sure we got this right. So we need a username and a host word. So we're going to say PPP. PPP. Authentication CHAP. So we're going to be using CHAP authentication, and so we've got that set up. But remember, we need to make sure that we have the username, or I should say host name, and password set up, which we do, and we set that up as a user. So we're going to say username, and the username is ISP in all caps, and then the password is going to be Cisco. Now I'm going to watch closely to my completion percentage here to make sure that they're not asking me to set that as a secret, which you cannot do. Remember, it's got to be either clear text or I should say type 7 or type 0 in terms of the password. So there we go. And so now we've got the username password configured for the authentication. So the line protocol has come up. So do show IP interface brief. We should be up, and we are. And let's see, do I have reachability here? Do ping. Let's see, can we ping out to 209.165.200.225? And we may have to ARP out there. I'm trying to get to the web server, and we cannot yet get to the web server. And let me see. I'm wondering here as I look down the configure a default route. Oh, okay. So I should have probably looked at step 2. That was going to be my next go-to, was do we have a route out there? So we're going to do a default route, and we're going to use the exit interface. So we're going to say IP route with a quad zeros. And the exit interface is serial 001. Again, remember that message there is not a concern because this is a point-to-point interface, so we're good. So now let me try to ping, and the ping works like it should. All right, so we've got our default gateway or our default route in there. Configure a static route to the LAN on R4, and says use the next hop IP address, not the outgoing interface. So we're on router 1, and we need a static route to the LAN to the 10.1.200/24, and it wants the next hop IP. Well, the next hop IP, since it's going to be over here on router 4, would be that serial, because they're all going to be, remember, this is a multi-point configuration here, and so everybody in here is going to be on the same subnet. In fact, it looks like it's going to be a slash, or it's a 248, so slash what, 192 or 128, 192, 224, 240, 248, so a slash 29, no, 28. Trying to do the math in my head here real quick. Yeah, 24, 29. So it looks like it's going to be a slash 29. And everybody in here is going to be, and actually it's right there in front of me, everybody's going to be on the same subnet in here. So the IP of router 4's serial 00 interface is going to be 10.0.0.4. So let's go ahead and create that static route. So we're going to say IP route. So to get to the 10.1.200.0, which is a slash 24, my next hop IP would be 10.0.0.4. All right, so that takes care of that static route, and now we're going to configure EIGRP here. So router EIGRP 100, it says advertise the entire 10 network and disable automatic summary. So no auto summary, that's the easy one. And then we're going to go ahead and say network 10.0.0.0, and then propagate a default route. So how would we propagate the default route? Well, the default route is already configured here. So there's two ways we could do it, right? Remember, I could do a summary, right? I could go to the interface serial 000 and do a summary with the quad zeros. But that's probably not what they're looking for. So since we've already done a static route for the default route, we're going to go ahead and say redistribute static. All right, so that takes care of propagating the default route. So configure a full, I think I say multi-point, so full mesh frame relay, right? So we're going to configure full mesh frame relay, configure frame relay encapsulation, and a map to each of the other routers. So the PVC to R4 uses IETF encapsulation, and the LMI type, right? And this is important, the LMI type here, since we're doing this as a full mesh, the LMI type is going to be ANSI. So we'll use ANSI for the LMI type. All right, so where do we start? Well, let's pick the lowest hanging fruit, which right now is simply going to be router 1, since we're already on router 1. Let's get into interface serial 000, right? And if I were to say do show run, let's take a look at serial 000 real quick. Right, so no encapsulation has been set. So that's the first order of operations, is we need to say encapsulation frame relay, right? So we get that set up, we hit enter, and you can see we're probably going to end up with a couple points from that, and we do end up with a couple points. So we've got the frame relay encap set to on serial 000. So now what was the next thing that we needed to do in those previous exercises? What do you think? What is our next approach going to be, or I should say our next set of commands that we're going to be running going to be? Yeah, so we're going to say frame relay and LMI type, right? You can see the LMI type is supposed to be what? ANSI. Absolutely. Now, since we're not doing point-to-point interfaces, there's a very good chance, and I think we want to do static, right? They're asking for us to do static. Yeah, configure static mappings to each of the other routers. So we're not going to be allowing inverse ARP, which, again, that is on by default, by the way. The inverse ARP functionality, that's on by default. So we're not allowing inverse ARP to run. So what I could say here is no frame relay inverse ARP, right? Because, again, I'm going to create a static map. And in the previous exercise where I had sort of fat-fingered the broadcast command and then tried to pull the entries out and it had already put them in there, that's because I didn't say no frame relay inverse ARP. So if you're doing a static map, chances are you're going to say no frame relay inverse ARP, so that you can then turn around and say frame relay map IP. So, excuse me, so the destination IP, so 10.0.0. And as router 1, I'm simply going to say 2. And then that would be what as the DELC? Well, they conveniently provide us a table over here, right? So router 1, and it sticks with that convention, 102, so 1 to 2, 103 for 1, 2, 3. And we'll use that convention as well. Obviously, we're going to use that convention or we're not going to end up getting the points. So 102. Now, I'm going to put the question mark here. What do you think? So you can clearly see we're going to be running EIGRP, right? So what do we need to do? Well, we need to go ahead and put the broadcast keyword in here, and then let's make sure I'm not missing anything here. Full mesh frame relay. So the IETF in cap is going to be important on the PVC to router 4, but the PVC here to router 2 and 3, we're going to go ahead and just leave with the default of Cisco. If I were to say do show run, I think do show interface serial 000 shows it as well, I believe. Put Q, there we go. So encapsulation has been set to frame relay, right? So we can clearly see that here. The LMI type, we set that to ANSI. So we're good to go on router 1. And I'm trying to make sure, I'm just keep looking back at the what it's asking us to do. Okay, so that takes care of the frame relay static map statement for router 2. Let's go ahead and we can just pull this up. This will be nice and easy to be able to say 103 and 10.003, and we're going to leave the broadcast keyword in there again, because remember, by default, frame relay is a non-broadcast multi-access in BMA, right? You hear that a lot, this in BMA. So when you look at DMVPN, which is really going to be replacing frame relay in all of the tracks, CCNA, NP, and IE, DMVPN is by default, because of the multi-point GRE, right, that generic routing encapsulation, but they have something called MGRE with DMVPN, and that is also point to multi-point, it's non-broadcast multi-access by default as well, and that's why you're going to see it replacing frame relay, in addition to the fact that frame relay is kind of, as a technology, it's really withering on the vine with a lot of other access topologies that are far superior. Okay, so we've got the map statement for router 2 and router 3, so now let's bring up the map statement for router 4. So 10.0.0.4. Now here, remember, what did it say? It said that it uses the encapsulation type is IETF. And so we're going to go with IETF as the encapsulation type toward router 4. So now let's take a look, do show run. Let's come down to serial 000, and we look pretty good. Frame relay type, the LMI type is ANSI. We're good there. The PVC to router 4 is using IETF. 2 and 3 are not. Those statements are in there, and the encapsulation is set. And I'm pretty sure the interface is no shut, so we'll just say no shut just for good measure. Okay, so that takes care of router 1. Now let's come down to routers 2 and 3. So this is kind of our first exposure to router 2 and router 3 here. So we'll stretch this out. Whoops. And this mouse is causing all kinds of issues here this morning. Bring it all the way to there. And let's jump on the command line for router 2 here. Let's get into privilege exec, and let's take a look at the serial interface here. So again, full mesh frame relay, right? We're not using sub interfaces. So we're going to use the entire physical interface here. We're all in the same subnet. It's a /29. And let's configure EIGRP. All right, so router, let's get into global config first. And let's say router EIGRP 100. And we're going to simply put a network statement in here for the 10.0.0.0 and then say no auto summary. And do not send EIGRP messages out the LAN interfaces. So router 2 has a single LAN interface, and I'm assuming it's gig 00. Do show IP interface brief. Let's make sure. Yeah, so it is gig 00. So we'll say passive interface gig 00, and that takes care of that requirement. And then full mesh frame relay. So let's jump into interface serial 000. Again, the order of operations in cap is frame relay. And then we're going to go ahead and set the frame relay LMI type to ANSI. So that takes care of that requirement. And now we just have our static map statements, right? So frame relay, map, IP, and again, this is going to be the destination IP. We need to create this layer 2 DELC to layer 3 mapping. So we're going to say 10.0.0.1, and the DELC from 2 to 1 is 201, and we need that broadcast keyword in there. All right, adjacency is up, right? Good to see that. So then we'll come back now. We're going to map from 2 to 3, 203, and this is going to be 10.0.0.3. And we haven't done 3 yet, so we're not going to see the adjacency there. And then finally 4, who is kind of our outlier here, IETF, and it would be 204 to 10.0.0.4, right? And so that takes care of the static mapping. So let's do one last look here at serial 000, and let's see how do we look. So the interface is up, the end cap is set to frame relay. We've got our 3 mapping statements to 201, 203, 204. To routers 1, 3, and 4 respectively. The LMI type is set, and the end cap for router 4 is IETF. So things look really good there. Now let's jump to router 3. So we bring router 3 into play here. And again, these activities are absolutely fantastic in terms of getting you set up and familiarized with the technology. So we'll go from user exec to privilege exec into global config. And so 3, it's going to be the same thing, router EIGRP 100. We're going to say network 10.0.0.0, and then we're going to say no auto summary, and same thing on router 3. Let's make sure that the it looks like gig 00, but let's confirm. Do show IP interface brief. Yep, so we'll say passive interface gig 00, and now we want to basically walk through the order of operations. So the first thing we do is we say, whoops, get into the right interface. It's the first thing we do, serial 000. And again, if you have those extra zeros, it's okay. Right, so I could say that, and it's still going to put me in interface serial 000. So in cap is going to be frame relay. Let's get our LMI type set up. So frame relay LMI type is going to be ANSI. And now we do our static map statement. So frame relay map IP, and the IP will be 10.0.0. We'll do router 1 first, .1, and the DELC from 3 to 1 is 301, and we need that broadcast keyword in there. Now let's do, and that's good, right? So we see that the adjacency with router 3 and 1 came up. So now we'll do 302. And good, the adjacency is up. And now we'll do, oh, and I forgot to say, so you know why it said that it says address already in map. So the reason it says that is because I forgot to say no frame relay inverse ARP under the interface here. So let me drop that in here actually. So no frame relay inverse ARP, and I don't know if you get points for that or not. And let me make sure on router 2 that was the command that we were missing. No frame relay inverse ARP. Again, not sure if they award you anything or not, but we should be doing that as a good practice, basically to ensure that it's our static mapping statements that are making things happen here. All right, so now let's pull back this static map statement, and we need to set up our mapping to 4. But remember that the in cap is IETF, right? So frame relay map IP to 10.0.0.4, 304 broadcast IETF. All right, so now we're going to walk over here to router 4, and it doesn't look like we're running. So that's why we have the static route here on router 1 pointing to this network here. So 4 looks like we're going to be using static routing instead of EIGRP. So let's pull this out here. There we go. Okay, so we're on router 4 now. So it says configure static and default routing. So we went from user exec to privilege exec. Let's get into global config. Configure a static route for each of the LANs. Okay, well this is unexpected here. So we're going to say IP route. So this is where running a dynamic routing protocol would be of benefit. 100.0, 255.255.255.0, because without it, take a look at what we're having to do. And for each LANs, use the next hop IP. So the next hop would be 10.0.0.2. So that's the static route to get over to the network behind router 2. And then router 3 is 10.1.150.0. So we're going to do that. So we'll say 10.1.150.0, and this is over to 10.0.0.3. So there's a static route for that. So we look good there. So that's 2 and 3. So we're good. Now configure a default route over to router 1. So IP route, the default route is my quad zeros. And we're going to use the next hop IP of 10.0.0.1. Again, that frame relay, right? Because again, remember, we're running a full mesh frame relay, and so I'm using that serial interface because we're all in that same 10.0.0.0/29 subnet. So we get that static default route. Now it wants me to configure full mesh frame relay, right? Obviously, we want reachability, which we don't have right now. So if I were to come to the laptop, let's confirm that we do not have reachability out to that web server. So let's try to ping 209.165.200.225. Yeah, and we're not having any luck. And the reason we're not having any luck right now is because we don't have a default route configured here on router 4. I know how to get to these networks. Do show IP route. Right, you can see that, and that's interesting. We have those static routes in there. Oh, okay, but it doesn't show them. That's interesting. Do show IP route. So we've got do show run. Hopefully we put them on here. Yeah. So funny that we have these. Oh, so not funny. Why are they not? And I love making mistakes because you learn the most when you're making your mistakes, right? So somebody tell me why those two static routes right there don't show up when I say do show IP route. So I just showed you that we don't have reachability to the web server because we don't have a default route out to the web server. But then I made the statement, well, we do have routes over here to this 10.1.100 and the 10.1.150. But when I say do show IP route, they didn't show up. And I was like, well, wait a second, did I not put those in? And then I look and I see that they're in here, so why don't these show up when I say show IP route? Something to think about, right? Something to think about. Because I don't have reachability to the next hop IP. Now, right here, after I put the IP, there's an argument that you can put there are use cases for it, but it's permanent is the argument. So if I were to pull back one of those route statements, like this one here, and do a question mark, it's not there on Cisco routers running full-blown iOS. Is it permanent or persistent? Give me a second here. Let's pull up. All right, so this is my 1900 series router. So if I were to go into global config and say IP route 10.1.100.0, we'll make it look the same as the other one. .0 and take the 10.0.0.2. Whoops. It's permanent, yeah. So you can see here, you get this argument that you can put in there which says permanent route. And what that means is if you don't have reachability to the next hop, you keep the route in the routing table anyway. So watch what happens. So I hit enter, do show IP route. You can see that I have no routing information. If I rerun that command, and hopefully this is going to do what I want it to do without having to make any additional changes. Yeah, well, it didn't. But if there were interfaces up and I have permanent in here, it would have kept this in here even if it had disappeared. And so the problem is over here is that's the exact issue, is I don't have reachability, and I've never had reachability, so it's not going to put it into the routing table. So let's go ahead and pull this back. So that's why now we need to configure that frame relay, right? So let's get into interface serial 000, in cap frame relay. Let's make sure we say no shut, just for good measure. And now the in cap and the LMI type is ANSI, so frame relay LMI type will be, will be ANSI, so we'll knock that out. And then configure a map to each of the other routers. And remember, going to each of the other routers, the in-cap type is going to be IETF. So frame relay, what do we have here? Frame relay map IP to 10.0.0.1. And the del C is going to be from router 4 to router 1. And are we doing broadcast here? Well, the answer is no. We're not running a routing protocol, but you can see I can make the in cap, because remember what we said in the first exercise we looked at was the broadcast is mutually exclusive from the encapsulation methods that you're using. So the broadcast is relevant if we're talking about running a dynamic routing protocol like an EIGRP, an OSPF, a RIP. Then we need that broadcast argument in there. The in-cap type is completely separate. It has nothing to do with whether we're running a dynamic routing protocol or not. It's all about the encapsulation type that's going to be used end-to-end here. So I can simply say, because we configured static routes to all those networks, I can configure, say, frame relay map IP 10.0.0.1 401 and do the in cap of IETF. And then I also want to say no frame relay inverse ARP. All right, so we got that taken care of. So now let's go ahead and drop in the next statement, which is going to be 402 over to router 2, and then 403 over to router 3. And what's interesting is that it didn't give us any points for those 3. But again, we're not running EIGRP. Let me see if that's what it's looking for. Does it want the broadcast keyword in there? Let's see if that changed anything. Do show run. Yeah, so we shouldn't have to put the broadcast keyword in there again because we're not running a dynamic routing protocol. And I'm just looking over here to make sure that we've got everything. In-cap frame relay, no frame relay inverse ARP. So that looks good. So now let's pull the laptop back up and see. Yeah, so I've got full reachability, right? So everything seems to be working. Now it says the end devices should be able to ping the web. So let's check all the end devices here. So the tablet PC, can it ping, the command prompt here, can it ping, let me move this out of the way, 209.165, 200.225. All right, it can ping, and then PC3, command prompt, ping 209.165.200.225. Okay, we got reachability there. Let's check PC2. Ping 209.165.200.225. All right, so we've got reachability from everywhere, but we're still shy some points. So let's do a quick check here and see what it is unhappy with. Yeah, so interesting, right? And that actually turned out to be what the problem was. So, and I think this is interesting because, again, the broadcast keyword is if we're running, you can see it's not preventing me from having and establishing full connectivity from all of the LANs that sit behind all of these routers that are running frame relay. So it wanted the broadcast keyword, but is the broadcast keyword required? And the answer is no, because we've set up static, or I should say, static routes to the networks, not only from 1, 2, and 3, we've set static routes up to the route, or did we set static routes on router 4? Let me double check here. Maybe I'm not reading this right. Did it want, let's make sure I'm looking at this. I don't think it said, yeah, no, configure static and default routing. Although on 2 and 3 we didn't establish static routes to the LAN behind 4, we did on a router. Yeah, so that's interesting that we're not running EIGRP here on 4. So we don't need that broadcast keyword. So anyway, that's why those 6 points are missing. And we could, clear everything out and put the commands back in to get the 100 points. So, but it's going to say that it's in there already, so I'd have to pull the entries out. So we'll leave it the way it is, because again, it's not running a dynamic routing protocol, so it doesn't need. And actually, right here, yeah, configure static routes for LAN 2, R2 and R3. So we're good there. So again, we're losing the 6 points, but that's okay. But at least you know that you don't need to put that broadcast keyword there because we're not running a dynamic routing protocol. We're not running EIGRP here, so it's not required. Okay, well, this is going to wrap up the skills integration challenge for Chapter 4. We did a little PPP and we did a whole lot of frame relay. And again, even though it's going to be phasing out of the curriculum for the CCNA, it's still, this is a great gateway into understanding non-broadcast multi-access technology, so that when you do transition to DMVPN and you start looking at multi-point GRE and DMVPN, that it's going to be kind of old hat. It'll be very easy for you to pick things up and then to understand, oh, right. I remember, for OSPF, I need to be aware of the network type. Is it point-to-point? Is it point-to-multipoint? Am I setting it to broadcast? Is there a DR-BDR election? All that will already be sorted out for you, so to speak. And then that, those things will be easy. Then you just need to learn the DMVPN syntax, which is not that difficult at all. All right, so thanks so much for watching, guys. Have a great week, and I will talk with you soon.